Alrighty, we are looking at some imaginary or potentially real compound with the formula CO with some amount of C's and O's. This is a mole ratio we're looking at here, but what they give you is a mass ratio. So the simplest thing to do is just to convert this into uh, an empirical formula type question. Just work out the empirical formula from here. If you do it like that, I think you can all do it fairly well. So here it is here. Divide both of those by their atomic masses, and we see that there are 2 and 4 moles of each. If you divide both of those by the smaller of the two numbers, we get a 1 to 2 ratio, which means that this is CO2. And that is all you need to do for number 3. Okay, well, let's save some imaginary paper here, and we'll do number 4 in the same video. We're trying to figure out the formula for a hydrate of a sodium sulfate hydrate, and they give you a bunch of data. Here it is here. Okay, so we see that we have a crucible that weighs 25 grams, and then with the hydrate in there, there's 30 grams. In other words, 5 grams of hydrate has been added. And then looking at the next number there with just the anhydrous salt, I see that I've lost. Sorry about that. Announcement got in the way. Anyways, I see that I lost 2.80 grams worth of water. And how much of the anhydrous salt do I have? Well, that's going to be the difference between these two here. So 2.20 grams of the anhydrous salt, that's that. And 2.8 grams of water is that. Okay? So then what I'm going to do then is take those two masses, convert them to moles. For water, I just simply divide by 18 grams per milliliter, and I get 0.156 moles. And then for sodium sulfate, I have to first of all figure out the molecular formula, or molecular mass, sorry, of sodium sulfate. And it is 142.1. And then if I divide 2.2 grams by that, it is 0.0155, okay, moles. And so I'm going to divide both of those by the smallest number, which is 0.0155. Do the same thing over here. Okay, and I get my ratio, which is 1 to 10. So that means my N value up here is 10, just like that. And that is a formula of the hydrate. And what the heck, let's just save more virtual paper and do number 5 on this video as well. Here we go with number 5. So they give you a percent composition, but like we've discussed before, you can just assume you have a 100-gram sample and all those percentages become masses. And in typical fashion then, we're just going to divide each of these by their relative atomic masses. Alrighty, and there's their atomic masses, and here are the molar amounts. Alrighty, so there are the molar amounts, and now we're going to divide all of those by the smallest number, which is 1.64, and that'll give me a ratio. There it is there, nice whole numbers. So here is my empirical formula, CH3NO2. There you go. Now, the question was asking, though, for the molecular formula, and they tell you that the molecular mass is 244 grams per mole. Well, the molecular formula for this particular compound is 61 grams per mole, and so we know that our molecular formula is just going to be some multiple of 61, and to figure that out, we just go 244 divided by 61, which is 4, which means I multiply this formula by 4. So in other words, C4H12N4O08. Sorry, there you go. And that, my friends, are all the answers to the review. Hopefully that answers all your questions. If not, you may have some time at the beginning of class to kind of ask a couple. Otherwise, hope your studying goes well. Have a great weekend if you haven't had one already, and we'll see you on Monday.